Hello everybody, I'm Storm here. Welcome back to Kerbal Space program. In the last episode, we kind of caught up with our ongoing missions. I've kind of put the whole mining base and space construction thing to the side for now. So I'm not entirely sure it's actually going to work now that I've spent all this time building stuff for it. I'm not sure it's going to work. So we're going to move on to something else, and I'm going to continue to look into that on my own for a little bit, and then if I can figure it out, then we'll come back. But we have other things we can do. And so we went around, got the ballista separated from the Kerbal on one station, got it into its own parking orbit. It's ready to go for another mission. Went and checked up on the Arbalest, transferred science home, advanced time a little bit. So that should all be good for the time being. And what I've decided to do next is to do a flight over to Eve with a manned vehicle and attempt to land on Eve. We have a little under a year. To do until we get to our transfer window. So, we need to start working on what it is that we're going to use to land on Eve and then return to orbit. Eve presents interesting challenges, primarily because its atmosphere is so thick. It makes landing quite easy, because parachutes have extremely effective performance in Eve's atmosphere. So dropping large masses onto the surface is actually fairly straightforward. The problem becomes getting back into orbit, because you need a lot of delta V to get into orbit to overcome all that atmospheric resistance. So trying to put together a lander that is light enough to make it to the surface without much trouble, and yet carries all the delta V that it needs to get back into orbit is going to be interesting. And the approach that I'm going to want to try and take here is to actually design and build an aircraft that should be able to fly in Eve's atmosphere so that we can actually get above a lot of that atmosphere and then attempt to get to orbit from a flying position rather than a landed on the surface position, and see if that works. The tricky bit about that is that there's no oxygen in Eve's atmosphere, so anything that uses intake air as an oxidizer and fuel isn't going to work. So we are going to need electric motors to make this work. So, this is going to be interesting. So, let's start putting something together, and this is going to be just a lot of design work this episode, and probably a few test flights, but we'll see. Because I'm figuring that if I can design an aircraft that flies well in Kerbin's atmosphere, it should fly excellently in Eve's atmosphere. So, that's the thought. So let's head on into the spaceplane hangar. And let's start throwing together something here. I don't think I'm going to need the thermal mechanics helper, though, you know, I'll keep that sitting around. Oh, have my volumes turned down a little bit there. All right. So, we're going to want to keep the aircraft relatively small, right? Again, because we're not going to really have a lot of power here. So want to keep this lightweight if we can. So what we're going to do is we're going to go for Mark II fuselage. We'll start with this cockpit for now. Here's our Clampetron docking port we're going to need. It also comes with some monopropellant, which is going to be good because we're going to need some monopropellant for orbital maneuvers. Now, since we're going to be using electric engines, well, actually, we're going to need to be bringing along a lot of liquid fuel and oxidizer because we're going to need... Or are we? Because we are going to need some sort of rockets to get us in orbit and a maneuver in space, right? So... what options do we have actually for fuels? Liquid ammonia, liquid argon, liquid carbon dioxide, dinitrogen tetroxide, hydrogen peroxide, hydrazine, and nitrogen tetroxide. That'd be a hypergolic engine. Liquid hydrogen, hydrolox, kerolox, kerosene, liquid fuel and oxidizer, hydrogen oxidizer, methalox, liquid methane, monopropellant, liquid nitrogen oxidizer. Okay. We don't have lithium as an option here. But I don't know if magnetoplasma dynamic thrusters are going to work for us because they're vacuum thrusters. And these engines, whatever rockets we put on here, are going to have to work in atmosphere. So if we did just liquid fuel and oxidizer, oh, that's not hydrazine and NTO. We want to do liquid fuel and oxidizer. And let's say we threw some toroidal aerospikes on there. What are we looking at? Thrust to weight ratio 1.9 with 2,500 meters per second at delta V. That's actually not bad to start with. Now, of course, this is pretty much not what we're going to be ending up with because we're going to have to throw some wings on here. We're going to have our engines. Alright. So let's just throw in some wings and let's see what we got. We're gonna put our canards on here. Kind of lay this out almost like we had our previous SSTOs. This is not going to be an SSTO for Kerbal. Okay, so there would be our wing surfaces. We need some vertical stabilizers, which I think we'll just go for kind of standard things here. Something like that, perhaps. And then we're going to need control surfaces. There. Alright, so there's a basic aircraft. Well, we don't have any landing gear on it or anything like that yet, but that should fly. We don't want USET for yaw. We don't want USET for yaw. We don't want USET for pitch or roll. Extended. Is that if we want to use those as flaps or something? Alright, so just throwing those wings and everything on there have reduced our thrust weight to 1.68 and our delta V to 2100. Alright. Now, we are going to need some sort of battery for these electric rotor engines that we're going to throw on here. Well, not engines, but motors. So, procedural battery. Let's see what we can do here. .25 meters. That gives me a electric charge of 9,200. Okay, now we're also going to need the rotors, which the rotors we're going to use, I was looking at this a bit on my own. We're going to be using these heavy rotors. Hold on, we just want this. So there they are. I think for texture on these, we're just going to want them plain white, I think. Alright, and then for these, we want them octo. Oh, actually, no, we don't want these doubled, because we're going to have to counter-rotate. Right. Okay, so maybe we put them on the ends? But let me just... We're gonna put one on here, and then we're gonna figure out where the other one's gonna go. Alright, then we're gonna need, propeller blades. There we are. Propeller blades. And then these are going to need to be deployed. I think, because I was trying these before, but that's the issue that I was having. I think that's the deploy direction we want. Deploy angle 60 degrees. Yes. Now, our one blade is hitting our wing there. So we're gonna need to move that forward a little bit. No, we're not. We're not doing that mirrored. we're going to have to do this to move it. Okay. There we are. Right. Now I gotta kind of eyeball. Where they are at. I think that's pretty close. All right. So, you're gonna be rotating this way. We're gonna need you to rotate the other way. I think that works. Now, what I'm gonna do... Actually, how much energy do these things consume? Electric charge 32 per second. Okay. That's gonna be another concern we're gonna have. All right. What is our center of aerodynamic lift, and where is our center of mass? Okay, that's good. Now, let's say... I wanted... Now, these should be mirrored. They won't be. Now our thrust weight is too low. Let's throw those on there because they're probably going to be on there. Make sure that center of mass is now too far back. Okay. Trying to think about how I might adjust that. Let's see, if I put that on there, it does move the center mass in front of the center lift. Okay, there we are. Thrust weight, not enough. Delta V, most likely not enough. But it's a start. It's a start. They could also throw engines on there. Now our thrust weight is above 1. Okay. Well, we're just experimenting. We're experimenting right now. All right. We're gonna need some sort of gear. Landing gear. Want to use the large ones? Whoa, 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 whoa. That is not what I wanted to do right there. I want to grab you. Medium. Right, and then you can extend your strut a little bit. Strut extension. That should work. Now, what this is also going to need is a probe of some description, so that we can control this thing without a pilot, because I do not want to fly this with pilots in there as the initial test, because we're probably going to blow up a few of these. Oh, and we need to have some sort of power generation. Let's see. How much did these use? Yeah, that'll work. A few of those on. Try and line them up as best I can. Ooh, that did not line up at all there. There we are. Okay. We'll call this Eve Lander 1. And let's put it on the runway. And let's see what it does. All right, now first thing I want to do is I want to lock the brakes. And then for these guys, oh, that's right, the brakes affect the. We put the brakes at 0, I guess. At least just for testing, anyway. Nope, that doesn't do anything. there's also something I want to figure out how to turn on. Just give me a moment. Okay, I think I've sorted it out. I wanted the aerodynamic forces, not the thermal display enabled. All right, so if we're gonna crank the torque up to, let's just say 10. Torque limit there. And let's take the brakes off and let's see what it does. Okay, actually that is working. All right, what kind of RPMs are we looking at here? Oh, all these things are steering. Steering lock. Steering lock. We're getting 80 some odd meters per second. Is this enough to keep it airborne? Ooh, come on, come on. Gear up. Okay. I'm actually going to go ahead and revert that flight back to launch. I don't know if we were getting enough RPMs off of those motors, but I got my blade angles and my rotor directions set correctly first time, which is shocking. But yeah, let's go ahead, throw the brakes on. Let's throw the torque up to 40. Make sure the torque is set to the same on both, or else this thing's going to fly all over the place. Make sure that your steering lock is back on. Make sure that your steering lock is back on. Also, probably want to disable the wheel authority on there. We don't want reaction wheel control. All right. Oh. All right, brakes off. Let's see if we get any more speed out of this. It definitely seems to be working better. What kind of RPM is we looking at? 420, 460 is the maximum. All right, they're at maximum RPM. We are getting a lot more speed. And we're taking off. Turn on. Actually, we probably want that reaction wheel authority up. I am still getting some torque here. I am still fighting some torque. The nose wants to come down. Might need some more reaction wheels. Yeah, that is definitely working. Just keep that nose up. Probably because this is just not a very good pro body. Maybe I want to actually keep get some Kerbals on here, but let me align this with the keyboard. And how are we doing for electric charge? Electric charge is not going down. I could probably make those batteries slightly smaller. Well, the one thing is that with these rotors, I really have no controls that will adjust their speed in any kind of smooth manner. I mean, I can throw the brakes on and they'll stop, but that's about it. Definitely still getting some torque. Even though these are... This one's rotating this way, this one's rotating this way. Alright, let's slap the brakes on and let's go into glide mode. Oop, oop. Oh, 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 oh. What? Okay, we still have some stability issues. You still have some stability issues. Alright, well, let's bring it back in and let's see. What might we do here? I think it needs a lot more lift. That's one thing it does need. I think it needs more wing surface. You guys shouldn't be doing anything for yaw. And, it consumes ore. Consumes fuel to make electricity. Interesting. if I were to go in here and put a reaction wheel. There. That might give it additional stability. Alright. Do I want to risk a pilot? Yeah, let's... how come we don't have any parts or crew capacity? What? Oh? Okay, now we do. Weird. Alright, we're gonna throw a pilot in there and we're gonna see... We're gonna see if this improves things. Also, we're gonna throw some more wing surface on here. We could throw that on. That's not a lot of additional wing surface. What about this? Might be better. All right. Let's save it. And let's try to fly it again. What do you mean it won't be controlled? What? Pilot, please. Thank you. Save. Launch. Weird. All right, lock those landing gear. All right, so we're going to go ahead and crank your torque up. 40% seemed to be sufficient. Actually, let me try maybe 25%. 25% torque. See if they can get up to the right RPMs. Let's get SAS set with those additional reaction wheels. Oh, make sure that your steering lock is on, because I think I forgot to turn that off in the assembly building, but that's okay. All right, and let's toggle the brakes, and let's see what it does. All right, yeah, we're up to 460 RPM. Takes off smoothly. Still wants to nose down. This is where an analog control stick would be nice. But I don't think I have my controller set up in the right in this version of the game, so I'll have to fix that. we're still, if I don't do anything with the controller, or anything on the controls, we're still rotating and nosing down. So, but that's something I could easily compensate for on a control stick. Rather than using the keyboard. It's very annoying on the keyboard. And then if I lock the brakes... and use the rocket engines... still wants to nose down. We have to rethink, and it still wants to rotate. I think that maybe we're unbalanced somewhere. I think our balance might be off. That might be what's causing part of the problem. Alright, let's see if I can put it on the runway. Get the nose up, nose up, please. Put her down, put her down, put her down. Oh, nice. Alright, and the brakes are on. Alright, it sort of works. It sort of works. Okay. Let's take it back into... the hangar. There might be a different way to do this. There might be a different way to do this. And let's give that a try. Make another version of this. Pull this off. Get rid of that. We're going to grab this instead. We're going to slap you on there. Come on. Get on there. Get on there. There you go. Got it. Alright, now there should be an adapter. I think I saw this one. We'll put that on there. I'm going to go ahead and I'm going to save this as Evelander 2. Just. Alright. And what we're going to do is I'm going to take... I need to, All those are on there. Oh, that's slightly annoying, but oh well. We're gonna slap you on there. Let's take you. And we're gonna do push-pull. All right. Now this one should spin this way, and that one should naturally spin the other way. And let's see if this one's gonna push the other one. We'll still need to flip that deploy direction around. Alright. There is an option. And then what I could do is just do this as a big delta wing. Larger delta wing with forward canards. Ooh. Why are we switching to that? We want this. Right? And then that? Or do you want that? Maybe that? Okay. And we'll definitely want to have this guy back on here again. Just so that we can do remote control. It's going to need batteries of some description. I mean, though these should provide enough power as long as it's in sunlight. Still gonna want some batteries. What can I do for batteries? Maybe those? Maybe I should undersling them. Yeah. Put them under there. Then... center of mass is way out in front. Okay. We're going to reorganize this a little bit. Let's actually get rid of you. And oh yeah, the docking port. That needs to be kept clear. And so with this, I'm just trying to think. Oh yeah, we need the batteries back on there. Actually, we could probably move those batteries a bit back here. I'll pull that center of mass back a little bit. All right, now let's say I were to throw these fuel tanks in here. Now that center mass is too far back. Let's see. That's pretty close, but again, we're too far back. Push that forward a little bit. All right. And then we throw our toroidal arrow spikes on here. Right. There's some nose cones. That gives us, what, 2,900 meters per second at delta V with a thrust to weight ratio of 0.94. We'd have to tweak that a little bit, but for now, that'd be something. All right, landing gear. Run extension to full. And I'll put those landing gear on here as well. With a little bit of strut extension. Not much. And make sure that these guys are steering locked. There we go. Let's try it out. Let's try it out. Oh yeah, we need the little control module, which I'll put there. And let's see if it flies. Getting this thing docked is going to be interesting. But we'll cross that bridge when we come to it. Getting a stable vehicle that flies properly, I think, is our first challenge. All right. Set our torque limit to, like, I don't know, 30. Did something just break? I don't know. All right, it seems to be moving in the correct direction. Make sure our RPMs are where they need to be. Kind of all over the place. I don't have any control surfaces. That's why I do it unmanned first time out. What are you doing? What in the world is it doing? Alright, I'm actually going to have to revert the flight because it won't let me do anything while it's actually moving. Alright, revert to the hangar. That's fine. We might need the heavier landing gear, actually. Let's try that. Just for how much mass it can hold. That's all you can extend the strut? That's insufficient. Alright, we'll need the medium landing gear on the front then. And the heavies on the rear. And actually, I'll probably want to flip this around. There we go. Alright, make sure the steering is locked on these. Make sure that the motor is free. We don't want the motors to do anything on these wheels because these wheels are not going to be powered. There we go. Get your strut extended. There we are. And we need control surfaces. Put a bunch on there for as much control authority as we can get. You're not going to be yaw. No yaw. No yaw. No yaw. Let's see. We're going to put... Put that on there for vertical stability, and just for some yaw control. All right, let's try it again. One more time. We're going to give these guys some more torque, probably 50% torque. All right, torque limit to 50. Torque limit to 50. And, let's see how she gets. All right, RPMs are at 460. We're accelerating effectively. Make sure stability control is on. Can we take off? We're still... No question. Yes, that was the problem. I had my controller connected, and it appears to have some dead zone issues, because it was providing control inputs when it shouldn't be. Now it's solid as a rock. That's a pretty good climb rate. See how much altitude we can get before we fire up those rocket engines. And then we'll have to see about how it might perform if we can get it in orbit. On re-entry, are these blades going to cause a problem on re-entry? That's going to be another question. Yeah, doing pretty well. This is going to be a lot slower than using the rocket-driven craft, obviously. Thing is that as we get higher in altitude, the air is going to get thinner, And the performance of the props is going to be a lot lower. If it wasn't carrying the weight of these tanks, it would probably be a lot better. We're starting to lose climb rate. We're just not moving fast enough for lift. That's about as high as we're gonna get. Alright, let's just see what the engines can do with the rockets engaged. Brakes on. We don't need the props. $16,000. We're only going to be suborbital here. 34, 35, 36, 37. $51,000 meters. That's not bad. We either need more efficient engines or more fuel. All right, well, we're through apoapsis, and now we're falling back through. And let's see what happens at high speed here. As we dart back down. Well, that worked. Well, I mean, they could turn the the props back on. And we are braking hard. Now we don't have the fuel on board. Doing fairly well. So let's see how it performs. Pull some pretty good G's. Yaw authority is actually pretty decent. I want to try and pull out of this dive. There we go. Yeah, once it's empty, it flies really well. Solid as a rock. And as far as electric charge, yep. Those panels are producing sufficient, though they're off center, and that's kind of annoying me. But that can be fixed. Alright, well, let's go ahead and put her down in the water, and then I think we'll call it a day here. But I think we can eventually make this work. I'm gonna have to refine the design a bit. But I can work on that off screen. Yeah, without the load. Flies really nice. All right, so yeah, we'll go ahead and stop here for now. I will continue to work on and refine the design of this craft, and then I think for next episode we'll try and get it into orbit and get it docked. That's going to be interesting. Especially since the ballista's in moon orbit, not Kerbal orbit. So, yeah. Yeah, that'll definitely be interesting. Alright, so, for now, hope you guys enjoyed it. Thanks for watching. Go ahead, like, subscribe, and comment, and I will see you next time.